Hello, pre-calc people. All right, so we are covering 6.5 and 6.3. I'm going to do them in that order. I've kind of modified the notes a little bit, so you'll just have to kind of find in your note packet the corresponding pages. So we're starting with 6.5, the second part that involves graphing, and we're going to do a continuation of your sine and cosine, but now in radian mode. So let's give a little reminder of what we're looking at. We have y equals c plus a cosine or sine b. Now what we're going to do is look at it in terms of x, which means radians. So remember that c is going to be your new sinusoidal axis, a is your amplitude, b, so first thing we do is we figure out what is the period, and then to find b, it will be 2 pi divided by whatever that period is. And then D is where you actually are starting your graph. So when we look at this, I think I will do this as a cosine graph because notice you have your high values clearly marked. This is going to be at 1. This is at 11. So to start off with, we see we're going from 5 to 1. That's a distance of 4. So half that distance would be a distance of 2. That puts my sinusoidal axis here at 3. That means my amplitude is going to be 2. My period is the distance it takes to complete one cycle. And so that is a distance. 11 minus 10 is 1 is 10, sorry. So we know the period is 10. Then 2 pi over 10 is what I would use to write the equation, which reduces to pi over 5. And I start the cycle at a positive 1. So once you have that, we can now write the equation, y equals 3 plus 2 cosine pi over 5 x minus 1. And this is how the order in which I will give them to you on, say, a quiz or a test, which also kind of helps because it's the order in which you would fill in the equation. All right, so there's our first radian mode. Now if we want to graph it, I'm going to kind of do the same thing. Let's identify what we have. Our c is going to be a negative 4, amplitude is going to be 5. Since I have 2 pi over 3, that's the b value. That means my period is going to be 2 pi divided by that, which is 2 pi divided by 3. The 2 pi's cancel, and the 3 comes up as just 3. So it's the reciprocal of 1/3, which is 3. And my phase shift is going to start at a negative 1, but that means I always like to also write down I'm going to end at a positive 2, because you always add these two to find out where I would start and where I would end. So I'm going to kind of spread this out. So here's a negative 1. That would make that a positive 1, and this is 2. And we want to go through and find all our averages. So halfway between negative 1 and 2, that's going to be 1. That's going to be at 1/2. That's going to be my midpoint. And then halfway between negative 1 and 1/2, if you add those together and divide by 2, that is going to put me at, that puts me at a negative 1/4. So I'll put that really close, negative 1/4. And then halfway between 2 and, sorry, I'm working this out, is going to be 1.25, so 1 1/4. So negative 1 and 2, and then I have my half and my quarter points. All right, so now we're ready to label our x-axis. So our new sinusoidal is going to be here at a negative 4. And my amplitude is 5, so I'm going to go up to 1 and down to a negative 9. So you add and subtract these two to get your y coordinates. And I do believe we are ready to, lost my pen. Ready to start graphing. So we're going to, since it is a sine graph and it's positive, we start on the sinusoidal. Then we go, let me mark out I just need that visual reinforcement to hit my highs and my lows. So then at -1/4, I have a high. And then at 1/2, I hit my sinusoidal. At 1 1/4, my low. And at 2, we end on our sinusoidal, and we want to make it look like it keeps going. So there we go. That would be your graph. Okay, so it's really about just finding averages to label your, in this case now it's an x-axis, and this is my y. Okay, we now have a cosine one down below. Let's kind of look at what we have. We know that our c value is going to be 3, amplitude is going to be 2. My b is pi over 4. That means that my period is 2 pi divided by that, by pi over 5. Pi's will cancel, and this becomes 2 times 5, invert and multiply. And then where do I start? I start at a positive 4. Now I realize you guys probably have a grid on yours. I hate graphing on a grid, so sorry I took mine off, but this should fit nicely anyway. So I'm going to label the x first. So we start, my new sinusoidal is going to be at 3. My amplitude is 2, so I'm going to go up to 5 and down to 1. So we have the y-axis marked up. Then I'm going to start at 4, and I will be ending at 14. So I'm going to put my 4 here. I'm going to put 14 out here. You guys can just count out your squares if you want. Everything should fit nicely on there. So half of 18, when you add those together, is 9. Then 4 plus 9 is 13, so that's going to be 13 halves. So that will be 6.5 right here. And halfway, 14 and 9 is 23. Half of that puts me at 11.5. So you have a 2.5 jump each time. All right, now we are ready, and it is a plus cosine. So that means we start high here at 5, hit your sinusoidal, go low, sinusoidal, end high, and we then fill it in with a nice curve. Okay, so radians, not that much different, but let's keep going. So now we want to look at our other 6, or our other 4 trig functions, since we have 6 in total. The first one is your tangent, the wave. The main thing to remember here is that the tangent of theta is the same thing as sine theta over cosine theta. So how does that help us? Well, that means that where sine theta equals 0, since it's in the numerator, and again that will happen at 0 degrees and 180 degrees, that means that your tangent will also be 0 there. So 0 on top means the answer is 0. However, where cosine theta equals 0, since it's in the denominator, and that's going to happen at 90 and 270, multiples of, so that means at those places, tangent is going to have an asymptote because it's undefined there. And then remember, in terms of your all students take calculus, tangent will be positive in the first, negative, then positive, then negative. It is that reason, because it oscillates positive, negative, that it only takes 180 degrees to complete one cycle. So the period of a tangent is always going to be just 180 degrees, or if you're in radians, pi. So let's look at how this would graph out. So every multiple of 90 degrees is going to be an asymptote. So I'm going to start back here at negative 90. Here's 0. Here's 90. Here's 180, 270, and 360. So we are going to have an asymptote at every multiple of 90 that are then 180 degrees apart. Now, trying to figure out what the graph will be doing, we know that we're also going to be 0 then at 0, 180, 360, all of those as we go along. Now, if you look at, we have broken this up from negative 90 to 0 on a unit circle. That's equivalent to quadrant 4. This would be quadrant 1, quadrant 2, quadrant 3 is from 180 to 270, and again we get back to quadrant 4. So in quadrant 4 we know that tangent is negative, but it has to hit 0, and then in quadrant 1 it's positive. So that means your graph is going to come up where it's negative, and now it's positive. And then it repeats, so that is one cycle. So in the second quadrant, it's negative again, comes up, and then it's positive. And the same thing would then continue. So notice it only took 180 degrees. So we tend to look at the tangent from negative 90 to 90 as sort of the main branch of where we graph it. Now your cotangent graph is very similar, except that now it's going to be cosine theta over sine theta, because it's the x over the y. So same thing is going to be true where cosine theta equals 0. That's going to be at 90 and 270. That means the cotangent will equal 0 there. And now wherever sine is 0, which again is at 0 and 180, etc., and I guess we have a cotangent x, you can convert that to radians. So at those places, cotangent will be undefined. And it has the same positive, negative value since it's just the reciprocal of tangent, which again means that its period is also going to be 180 or pi. All right, so if we label, so here we have our 0, here is 90, here's 180, 270, 360, and I could keep going. I'll put a negative 90 back here. So remember, it's also cotangent, which means it's complementary to the tangent. What that means is it is basically a 90-degree shift of your tangent graph. So wherever I am going to be hitting 0 or 180, I'm going to have an asymptote because that's now undefined there. And so at 0, 180, and 360, there are my asymptotes. So remember, this is now quadrant 1, quadrant 2, this is quadrant 3, this is quadrant 4. So in the first quadrant, cotangent is positive. It'll have to cross 90 at 0 and 270 at 0. So now our graph is going to come down because it has to be positive, then negative. There's your first cycle, full cycle. Then we come down, and it's positive, then negative. So for the cotangent, we tend to look at the main branch is from 0 to 180 to complete one cycle. All right? I'm not going to worry about amplitude because there isn't really an amplitude on these. It can kind of stretch out. You can have a vertical dilation, but it's really hard to show that in your graph, like specifically, and I'm not going to have you plot a lot of points. So in terms of transformations, the most I expect you to do is a horizontal shrink or stretch, okay, with tangent and cotangent. Really, I've never had to deal with anything beyond that. So I'm going to show you a little hack on this. I'm going to graph the basic tangent graph, and then we're going to show how you would then transform it. So our basic graph, since that says x, I'm going to do this as negative pi over 2. I'll put it in radians. And this is pi over 2, and our parent function just kind of would look like this, positive, negative, okay? That's just the y equals tangent x. Now that 2 there, remember the horizontal always acts the opposite. That 2 means that we are going to be shrinking by a half. So what that means is you're going to be multiplying the x values, because we're shrinking horizontally. So you're going to multiply your x values by 1/2. So I actually don't change anything. It's kind of cheating. I just multiply everything by 1/2, and now I relabel it. So this is actually negative pi over 4. This is pi over 4. You really should then get rid of this label. So I'm going to now make it go away. And the graph is going to be exactly the same graph. We just have our new scale. So I know it's kind of cheating, but it is exact, you know? It's all about how you've labeled it and showing our asymptotes, and you're still negative, then positive. That's your graph. Okay, we can do exactly the same thing for cotangent. Now I notice yours also says theta minus 45. You can just cross out that minus 45. I'm not going to have you shifting. Nobody does it. So it's like, why make you suffer through it if no one does it? So here's my 0, here's 90. We're going to first just put in, because this is theta, so I'm doing it in degrees. So our normal graph would have the asymptotes at 0 and 80, but now so that's going to represent your y equals cotangent x. So remember, that one starts positive and then gets negative. The 1/2 means that we are going to stretch by a factor of 2. So that means I'm going to be multiplying my x values, because again, this is a horizontal stretch. So I'll multiply everything by 2. So 0 times 2 is still 0. 90 times 2 is going to become 180. 180 times 2 becomes 360. And voila, there is my graph. All right, so just please either erase or make it very clear what your new label is, rather than just a messy cross out and rewrite it. And I'm okay then with just doing that. So now let's look at our cosecant and secant graph. Again, I'm not going to really worry about the amplitude. The period will still be 360 or 2 pi, depending on your degrees or radians, because cosecant is just the reciprocal of your sine. Everything else would here be the same. What we will talk about is your domain and your range, but let's first look at the graph. So what I'm going to first graph is the sine. That's what I would always recommend you to do. So my sine, which is the reciprocal, I'm going to do it in a light orange. So y equals sine x. So we know we have 0, here's 90, 180, 270, 360. I could go back to negative 90. I don't think I need to. I'm just going to put dots on the graph that represent my sine. So usually sine goes from 1 to negative 1. That's your high and your low. So a sine starts on the sinusoidal, goes high, sinusoidal, goes low, sinusoidal. So now we want to think about what is the reciprocal of those values. So the reciprocal of 0, anywhere that I hit the x-axis, well, the reciprocal of 0 over 1 is 1 over 0, which we know is undefined. So wherever you hit your sinusoidal, that is going to be an asymptote. So here's our asymptotes. Now I have these highs and lows. The reciprocal of 1 is 1. The reciprocal of negative 1 is negative 1. But if you think about the values of your sine, the reciprocal of a small number is a large number. So these graphs basically turn what was an upside down, concave down into something concave up, sort of like a parabola. And so then we just do little parabolas off of the high and the low. That completes one full cycle of 360 degrees, and that would be your cosecant graph. We can do exactly the same thing with the secant graph. So I'm going to put my labels on here. So 180, 270, 360. So we know that secant is going to be the reciprocal of cosine. And in this case, oh, we were in x. Sorry about that. I should at least try and maintain the same thing I'm going to expect you to do. So x means I should be in radian mode. So put these back into radians, pi, 3 pi over 2, and 2 pi. There we go. So if it was a cosine graph, I know that I would start up here at 1. So I would start here, then it goes here. Pi, you're at negative 1. Here you're at 0. 2 pi, you'd be at 1 again. That also means going backwards at negative pi over 2, I would be at 0. Those mark off your cosine. And once again, Wherever you're going to hit the sinusoidal, the reciprocal of 0 is going to be undefined, so this will be an asymptote, this will be an asymptote, and this will be an asymptote. And we see our highs and our lows, same concept. So now I do an concave up parabola for the high and a concave down parabola for the low. And I could keep going. I'm just going to do a little portion there. And notice, so now we're really, for secant, you're going from negative pi over 2 to 3 pi over 2. I would rather talk about the domain and range in class, but let's just notice here that you have nothing between 1 and negative 1. So your range, where can I write this down for the both of them basically, is going to be, there's two ways you can write this. You can write it as the absolute value of y greater than or equal to 1. Or we could write it as, let's say, negative infinity up to a negative 1, and then also from 1 up to infinity. That would represent the range for both of them. The domain, that will switch. So the domain for the cosecant, it's going to be all reals except at 0 and every multiple of 180 degrees, you'll have an asymptote. Oh no. Okay, give me 1 second. All right, I wanted to finish this before everyone starts coming into class. Okay, so graphing this last one, it's a cosecant, so really what I'm going to do is I'm going to graph a sine graph. So I notice that my C is at -1, that's my new sinusoidal. So this is -1. Amplitude is 2, so I'm going to go up to 1 and down to a -3. And I'm going to draw these. And we have a period that is going to be, so we're in radians, so 2 pi over 2, which is a distance of pi, but we are starting at pi over 2. So I'm going to start here at pi over 2, which means I'm finishing, pi later would put me at 3 pi over 2. Think about 90 degrees, pi distance would put you at 270. And then the halfway point between 90 and 270 is pi. Halfway points are your 3 pi over 4, your 135, and your 5 pi over 4. So again, if I were to put my sine graph on here, sine starts on the sinusoidal, goes up, sinusoidal, down, sinusoidal, and then I guess we're going a little bit. Oh, I didn't start at pi over 2. All right, sorry about that. Good thing I didn't draw any graph yet. So let's see if I can just make those dots go away. Yay, that worked. Okay, sinusoidal at pi over 2, then the high, then your sinusoidal, then down, then your sinusoidal. So wherever you hit the sinusoidal, that is going to be an asymptote. So I have my 2 asymptotes, and wherever I have the high, I do a parabola off of the high and a parabola off of the low. So I'm not actually graphing my sine graph, I'm just putting sort of the placeholders so I can do my high, my low, and my asymptote. I hope that helped.